welcome back to my video. My name is Tasya Natali Sihombing. I am college student from Mathematics Education Study Program 2019 at State University of Medan. In this video, I will explain about chapter 13 is the Scientific Revolution period. 17 years century witnessed an unprecedented increase in mathematical and scientific ideas throughout Europe. Galileo 1564 to 1642 AD was able to observe Jupiter's moon with his homemade telescope based on toys imported from Holland. 1601 managed to collect a large amount of mathematical data describing the position of the planets in space. Johannes Kepler studied the motion of the planets seriously and put forward Kepler's law. René Descartes developed analytic geometry by placing the orbits of the planets orthograph of Cartesian coordinates. However, his service in mathematics should not be underestimated. His most famous work in the philosophy Natural Principia, Mathematics Principle of Natural Philosophy, which was first published on July 5, 1687, in formulation his physical theory, Newton developed a method that we know today as calculus. Newton calculus at time this used a different notation from modern calculus notation. Because of this, Newton is considered one of the founders of calculus. Another discoverer of calculus was Georg Wilhelm von Leibniz. He is considered one of most important mathematicians in history. In his calculus, Leibniz introduction a notation that is still widely used today. He was the first to understand that the coefficient of a system of linear equations could be arranged in rows. We now call them metrics to find solution to the system of equations. This method was later called Gaussian elimination. Leibniz is also known as a polymath and philosopher. Apart from astronomy and physics, the application of mathematics developed in new direction. Blaise Pascal and Pierre the former teamed up to investigate probability theory and combination rule in their condition of gambling. 18 years century, the most influential mathematician of the 8 years century was arguable Rainer Euler. One of his contribution was the discovery of the study of graph theory with the 7 branches of considered far-standing many modern mathematical terms. It represents the square root of -1 with the symbol a. He also popularized the symbol p to express the ratio between the circumference of the circle and his diameter. Graph theory, calculus, combinatoric, and complex analysis. Another important mathematician of the 18th century was Joseph Louis Lagrange, who did pioneering work in number theory. There was also Laplace, who had done important work on the foundation of classical mechanics and statistics. Modern era 19th century. During the 19th century, mathematics became increasingly abstract. Carl Friedrich Gauss, known as the Prince of Mathematics, made revolutionary work on complex variable function and the convergence of series. Fundamental theorem of algebra and the quadratic reciprocity law in this century also developed 2 new geometric shapes beside Euclidean geometry. The Russian mathematician Nikolai Ivanovich Lobachevsky and his rival Janusz Boyle, the Hungarian mathematician institution separately defines and studies hyperbolic geometry, while one other firm, namely elliptical geometry, was developed by the German mathematician. He also developed Riemannian geometry, which suffices and broadly generalized the three types of geometry and also defined the concept of the manifold, which generalized the notion of curves and surface. The 19th years century saw the beginning of much abstract algebra. William Roman Hamilton in Ireland developed the non-communicative algebra. The British mathematician George Ball defines an algebra that soon evolved in both algebra, which contain only the numbers 0 and 1. Augustin Louis Cauchy, Bernhard Riemann, and Carl Weierstrass revolved calculus in a more rigid way. In this country too, for the first time, the boundaries of mathematics were explored. Neil Henry and Ferris Gars proved that there is no general algebraic method for solving polynomial equations with more than 4 degrees. Limitation in geometry was excited in the 19th century by considering the parameter space and hypercomplex number. Abel and Goyle's investigation into the solution of various polynomial equations laid the foundation for the development of group theory as well as fields related to abstract algebra. In the 19th century, several mathematical communities were established. There included the London Mathematical Society in 1865, the Social Mathematics the French in 1872, the Edinburgh Mathematical Society in 1883, the Calder Mathematics 1884, and the American Mathematical Society in 1888, and the Quaternion Society in the 1899. Every year, thousands of doctoral PhD degrees in mathematics are awarded, and there are many jobs available in education and industry. In 1900, David Hilbert, in a speech to the International Congress of Mathematicians, present a list of 23 unsolved problems in mathematics. These problems, which covers many areas of mathematics, become the main focus of much of the mathematics of the 20th century. Currently, 10 have been solved, 7 have been partially solved, and 2 are still open, and 4 issues have yet to be declared solved or not. In 1976, Wolfgang Haken and Kenneth Apple used computers to prove the four-color theorem. Adra Wills proved Fermat-Less theorem. In 1995, in 1998, Thomas Callister-Hall proved the Kepler conjecture, mathematical collaboration of unprecedented size and scope, an example in the classification on finite simple groups, whose proof between 1955 and 1983 required 500 journal articles by about 100 authors and fills 10 of thousands of pages. Entirely new fields of mathematics such as mathematical logic, topology, and game theory have changed the types of questions that can be answered by mathematical methods. All types are structured or abstract by axiom and give names like magic space, topological space, etc., the concept of abstract structure relates to category theory. Grothendieck and Serre reconstructed algebraic geometry using safe theory. The continuous development and improvement of computer allows industry to deal with large amount of data of facilitate mass production, distribution, and communication. With this development, new fields of mathematics have also developed, including Turing, computability theory, complexity theory, data analysis, and optimization. And next, network make the concept of discrete and combinatorial explanation even more important, including graph theory. The ability and speed of data processing on a computer enables the handles of mathematical problems that take too much time to do with pencil and paper, leading to fields such as numerical analysis and symbolic computing. Some of most important methods and algorithms of the 20th century include the simple algorithm, the fast various transform error correction code, the Kalman filter from control theory, and the Iris algorithm for public key cryptography. Country was Srinivasa Iyengar Ramanujan, who had guessed and proved more than 3,000 theorems, including properties of very high complex number, as well as Hoch's theta function. He also made major investigation into gamma function, modular forms, divergent series, hypergeometry series, and prime number theory. And then in 1952, namely USGSM, the University of Illinois, Committee on School Mathematics, which emphasizes understanding and discovery, because this project in the firmament or modern mathematical as leader of project. Modern mathematics, one of them created a modern mathematics move, which is a continuous of the USM project, namely the SMSG School Mathematics Study Group project led by Dr. Beagle, the result of which were able to make a big difference not only in America but around the world. The Clay Mathematica Institute announcement 7 Millennium Prize problems, and with the Poincare conjecture was solved by Grigor Perelman, who refused to accept the award because of his critical attitude towards the establishment of mathematics. Many mathematics journals now have online versions such as the print version, and many journals are only published online. The most notable of which are that the subject is getting bigger, computers are getting more important and powerful. The application of mathematics to bioinformation is growing rapidly, facilitated by computer is exponentially growing. Okay guys, I think that all my explanation about topic Science Revolution period. Please forgive me if I have mixed it in my explanation video. I hope I will be better in next chapter. If they are criticism or suggestion, you can write in the column comment. And I hope my explanation video is useful for you. Don't forget to share this video. With your friends on social media, and turn on the notification bell to get the latest on the topic the Science Revolution period. Thank you guys. Have a good day.